All right, thanks for coming back. Hope the lunch was nice. Hope it was worth the wait. I enjoyed mine. We've got Amy up next. Amy is another person that's just been such a pleasure to know over the years at DevWorld and other sort of AUC adjacent events. I'm going to read you from her description here because I just really like this. Amy describes herself as a soft and squishy iOS and macOS developer who loves to push the limits of what is possible with Apple's frameworks and products. Amy's from here in Melbourne, but she is often found traveling the world. And I can tell you that one of the things about following Amy on Twitter or more recently on Mastodon, it is an endless source of FOMO because it's just like, where is Amy now? Oh, Amy's in Tokyo. Oh, Amy's over in California. She's kind of like an Australian Carmen Sandiego kind of thing going on. So such a pleasure to have you again. Please make Amy feel very welcome.
Okay. Thanks, James, for that intro. It's always good to be back at DevWorld, which is a fun conference, been going for many years. So yeah, good to see many regular faces and also people that are new. I am here today to talk about my cycling app, which is one that I've been building over the years, but particularly today it is to talk about going from importing files to playing back those files in a replay, and then also looking at live recording of the data via Bluetooth sensors, call location, all of the fun things, so that while you're out cycling, you can be tracking your activities. Now, today being the 31st of March, it is also the Trans Day of Visibility. So one of the non-negotiables in life is that trans rights are human rights, and there shall be no disagreement. Okay. So one day as I was climbing a mountain, most cyclists will know this, they're just out on a very quiet country road and they're making their way up a hill, up a mountain. This particular one is from just outside of Daylesford, where I will happen to be on the weekend. Yay, travel. Daylesford is in central Victoria, for those that are not familiar with the area. Now, as I was cycling, now this is going back years rather than when the photo itself was taken, I had a dream about what would make a really amazing cycling app. So one of the things that I thought, okay, you're trying to collate a whole heap of data. So you want everything there quick and easy to find. So a single app, rather than sort of, okay, you've got Strava for this, Garmin for that, radar sensors for something else, you've got DI2 stats for all of your gear changes. Instead of relying on other people building products to their needs, why not just throw it all into a Mac app, which is what I did and have been building over the past couple of years. One of the approaches I've been taking as well is to rely heavily on Apple's frameworks. So things like the Swift language, no Objective-C, not even an Objective-C wrapper around a C++ framework. It's all C framework to Swift. Cut out the Objective-C. Sorry, Tim. The other thing that I wanted to do with this is have a really deep integration with platform features, particularly on macOS. Do stuff like core Spotlight searching, which means when you enable Spotlight, you're able to start searching for your rides directly from there and then have it open up into the app. So what is the app? The app is RideStats. RideStats.app is the domain for a website that needs a bit of love and work, but at the moment it is a multi-platform app, being macOS, iOS, and iPad OS. It is full SwiftUI. There are no AppKit or UIKit bridges in there. It is all in SwiftUI, which is quite amazing. While I was traveling to San Jose last year for DubDub, which was really good, I spent about 30 minutes and threw out my existing charting library and implemented Swift charts and got a whole heap of benefits as a result. Another thing that is in there are widgets. So you can put a widget either into macOS, sadly no one really does that, or on your home screen on an iPhone, and you'll be able to see what your latest ride is. The really fun stuff is what I'm building at the moment. So Siri shortcuts will be coming into a version sometime soon, as well as live recording, being you see the data not only within the app as you're out cycling, but also have it as a live activity or make use of the dynamic island. Some limitations of doing things within the realm of sport fitness, of putting a cycling app together, is you've got these rather large industry players who are out there and have very significant names. So you're trying to compete against them. So these are people like Garmin, Wahoo, and Strava. Within cycling, and particularly when you chat with friends, there's always this saying of, if it's not on Strava, it didn't happen. So that's the kind of bias or the preconception you are working against with all of this. And there's also limitations on the hardware. So if you've ever been outside on a bright sunny day, particularly in Australia, you can't see your iPhone screen. And that's a fair problem. What we've got so far, and what I'll be talking about to begin with, is importing your files that are called .fit files, which is a standard that Garmin has developed. As a standard, it is designed for really small cycling computers and lots of data, which means you're dealing with bits and with bytes of information, and when you're passing it, you need to scan through everything in sequence and do logic based on, okay, it's this length, we've got this bit at the start, or that bit is set, and it becomes pretty fun if you enjoy that stuff. For all of that side of things, just use the C SDK that Garmin provides and wrap that into a Swift package and interact with it directly from Swift. It is a macOS and an iOS application, so the one code base, the one Xcode project, the one target is designed to work with both macOS and iOS. This is all possible because of SwiftUI and the recent developments of that framework. And it replays the rides, so you'll be able to track in a sped up fashion all of the data coming in, which is pretty cool. I actually built that replay functionality as a way to test out some of the UI for doing the live tracking, and went, you know what, this is actually a pretty cool feature. I will just release this as is, and hopefully people will get a lot out of it. Okay, importing files. This is the fun thing. Again, SwiftUI makes this so easy. You get a file importer as a function you can call on a view, and it will present an appropriate document picker, which will be either for macOS or iOS or iPadOS, and allow you to then read in the files. All of this is done using async await because it's the future and you should all be adopting it, and it's pretty cool. That's the super simple and easy side of things. Then we get into the replaying of the rides. So once everything is built out onto the screen and you're seeing graphs and maps and all this fun thing, you can then hit the replay button and it will show this particular view. This is the Mac OS version. It'll look fairly similar on iPad, and on iOS it is a sheet. Again, SwiftUI makes this super simple where it's the same view just presented in a native way on each of the different platforms. So to do this, I am getting a timer publisher, and then based on each event that is going through, I look at how much should I progress with the timestamp it's showing, and away it goes. Yeah, this is pretty cool. Scrubber there so you can go forward and back through your ride, see particular bits of data, where you are and whatnot. This ride was up in Hepburn. This is the one I took the photos on at the start of the presentation, up Bald Hill Road, which is the far right side of that map, which is very faded out, and then sort of back through into Dalesford, which is the bitumen climb there as well. Okay, now we get into the fun stuff, which is what I've been developing over the past couple of months and where things will be going. So in order to do live tracking of data, we want to start talking with Bluetooth devices. These are things like your power meters, your heart rate monitors, potentially a radar monitor as well. If you're a cyclist and don't yet have a radar, it will tell you of upcoming vehicles that are going to be overtaking you. So particularly for country roads, you can then start getting out of the way if you know that the car's being annoying. Another bit of data you need to start pulling in is core location, because so core location is stuff like your GPS location, your speed and your altitude, all really important bits of data to be working with, and a lot of cyclists when they're outdoors will be relying on those bits of value. Apple Watch, again, the Apple Watch Ultra, amazing device, probably the first one that's like just there for use by cyclists, in that it's got a really long battery life and you can use it on like a 5, 6, 7 hour ride without much issue. Live activities, again, great innovation that Apple has introduced, and that means you can turn off the screen on an iPhone 14 Pro or Pro Max and have it show there as the live activity, or if you background your app, it'll be there in the dynamic island. This again means that you will have less data drain. If you're out on a 5 hour ride, that is what you want. So moving parts. Earlier today, Tim gave a talk about some dependency injection stuff. Like a lot of people and a lot of different companies, I use a thing called a service, in which is injected via a property wrapper. And this is just the entry point or collator for all of the different bits of sensor data, being Bluetooth devices, Apple Watch, if you're using that for heart rate, or your core location, in order to get a record of what is happening at a particular point in time. Cool. Live activities, again, a very similar architecture where the workout service is then funneling data across to the live activity service, and the live activity service is then what is generating your configuration for the widgets. Cool. We will be going into this in a bit more detail shortly. Bluetooth devices. This is the fun stuff, and it gets super, super nerdy. I was up in Sydney a couple of weeks ago giving this same talk and went into a lot of depth on the Bluetooth side. I'll be taking a lighter approach this week, but if you want to look at the Sydney Cocoheads talk, I'm probably saying the same things, just in a bit more depth there. So what's going on when you're talking to a Bluetooth device? You've got this thing which is handling all of your connections, and that can know about multiple devices. Each device has a primary service, which is the main thing you're interacting with, but it can also have secondary services. Each of those services then have characteristics, and it gets pretty complex when you're doing the connections and then trying to figure out what it is that this particular device is providing you and working with it. Okay, time for some code. Probably not the best code to take out of context, but this is one of the delegate methods. Yay, delegates. They've been around for many, many years and are actually a really good way of having one thing talk to another. This other thing says, hey, I'm this first thing's delegate. First thing knows that when it gets to a particular point, it'll just go, okay, how do I handle this? I don't know. I'm going to delegate it across to the second one. It makes sense in the English language. So here, the Bluetooth manager, an instance of CB central manager, CB being called Bluetooth, is calling this delegate method saying, hey, I have discovered a peripheral. Then do logic around it based on what it is you're wanting to do. I'm storing it off in something that is applicable to a user interface. And when the user wants to connect to it, we get this second delegate method called, which is our did connect. So you've told the manager connect to your peripheral. You get this delegate method called as a result because it's all async and works really nicely. Once you've done that and you've got the connection, you then want to say to your peripheral, what are the services that will be advertised, that you are advertising and I should listen to? You've said, hey, let's go and fetch out those services. And as a result, you get this delegate called, which is saying, hey, here are my discovered services. Cool. The CB peripheral instance now has the services property actually populated with an array, and then you iterate over them and you go, well, here, go for this peripheral, please go and discover the services, and we get to another characteristic. The characteristics, which is another delegate method that gets called. Here the manager is saying to whatever conforms to the delegate that it will have a bunch of, it has now discovered those characteristics on the peripheral. This gets me very tongue-tied because it's like peripherals and services and characteristics, and it is actually it is well designed, even though it is a bit difficult to get your head around if you're not used to dealing with these devices. Cool, okay, so we've got our peripheral, we've said go and find the character services, and then go and find the characteristics. Now we're at a stage where we want to go and read the actual values. So when getting values from a Bluetooth device, there are two types. One is just read a constant value that the device holds, and the other is be notified when the device has a value. So with the something like a power meter or a heart rate meter, you want to be notified when they have a new value. And this is what happens with this delegate method. So it will say, okay, our peripheral has received a value, which is some data for a characteristic, and you then need to go and interpret it. These bits of data are typically byte strings, and they will always conform to a particular, standard, which says, okay, if you've got this first bit set as this, then the next couple of bits will be this other thing, and if it's a particular value, you might be combining in some extra stuff as well. It's all pretty cool, but you need to be fairly familiar with the way standards are written and enjoy working at that level of data. Once you've this is a representation of extracting the data from a power meter, which in this case has crank revolutions. So each time you turn the crank on a bike, it is reading the value. That value is accumulative, so you will know, okay, you've progressed, you've done so many revolutions. You then also look for the event time. The event time will tell you, okay, for power sensors and crank values, it is each event time increment is 1/1024th of a second different. So you have to be pretty comfortable with maths, because that will allow you to go from, okay, one revolution over this really short time is equivalent to something like 80 revolutions over a minute. Maths is good for that. Not only maths, but unit tests. Always unit test this stuff, because it gets fairly gnarly, and cyclists particularly are very pedantic around the data that they get, and they want those really fine but super accurate values there. Cool. That's a lot, and it is just covering getting a value off a device and consuming it in the app. Okay, bit of a side journey now to talk about measurements. So I talked about increments in crank increments in crank revolutions over a very, very small period of time. Now, that is one particular unit of measurement, but is different from how it's typically consumed or displayed on an app, which might be in revolutions per minute. So in order to get there, Apple's Swift library, and particularly the Foundation framework, has a measurement unit in it that allows you to specify a value over a particular length or a particular speed. So it's always good to be associating the values you get from these devices as both a measurement and a unit of measurement. So you then, when displaying it, will put it as what the user wants. An example is, okay, are you talking about meters or are you talking about kilometers? Most of the measurements you get from devices are in meters or in centimeters, but when they get displayed to a user, it will be in kilometers or kilometers per hour. And then you have these things called miles, which the UK and America choose to use to cover distance. And if you've got something in meters and you're wanting to, and the user has said, well, I'm American, I think and talk in imperial units, you need to do the conversion. So always associate a value with the unit of measurement. Okay, we then have another question of when do we want to be doing this calculation or display of the values? Well, for me and my particular use case, I'm keeping it in the base units of measurement, so what I take up until that very, very last point. So try and keep everything in the same unit of measurement until it gets displayed by using the measurement type. I'm able to do that conversion fairly easily at a view model layer and have it displayed to the user. Cool. Okay, live activities. This is the fun stuff, and this is what Apple revealed during DubDub last year, and also with the iPhone 14 Pro being the dynamic island. So the idea here is to have something that is glanceable, so you're not needing to look at it constantly. Taking your eyes off a road is a very bad idea, so you just have something you can look down to and get an indication of what's going on at a particular point in time, and get back to paying attention to the road and to your cycling. These work on the lock screen, which is really good because then you will have the display dimmed and you're not distracted by icons or anything like that, and it is using a lot less power in order to show this information to you. The dynamic island is a bit more appropriate, say, if you're on an indoor trainer. An indoor trainer, you'll be inside, you're not so worried about your power drain as much, and you might be using your phone if you're just sort of spinning or something like that. So for a dynamic island, there are a couple of different versions of it. You've got the compact display, you've got the leading and the trailing items in it, and then you've got the expanded one as well, which is cool. How do we implement all of this is by the use of widgets. So in your widget bundle, you just need to check that it supports or has an iOS version of 16.1 or above, and then you can put in your widget there. In the info.p list, you also want to be putting in a supports live activities flag, set it to true, and make sure you've got the appropriate availability checks around everything. The widget creation itself is like other widgets, and you have a configuration there, so the widget will get displayed on some static info that gets passed to it. Point of disagreement with Tim's talk is when he talked about static view models, they're probably closer to configurations because configurations are designed to be immutable. With configurations, though, you are wanting it so there is no business logic being accomplished. Business logic goes into a view model. Your actual sort of static content and data with the configuration is there. It doesn't change. It's, hey, here's something at a point in time. So Apple uses this with the way that live activities work, where you have this outer container being your attributes, and then has content there as well. So your attributes are your completely immutable stuff, like what's the name, what's the start time, or something like that, that will not change for the life cycle of your activity. And then you have the changeable data being your content. All of these conform to activity attributes. These slides are a little bit old. Apple has updated things a little bit, but it'll give you a general idea of what it is that is going on. Again, everything just feeds back into the live activities, which are the widgets, the start of the activity. So once you've got all of your types defined, you then want to be creating a live activity and holding a reference to it. That reference is what you use later on. But so you create your attributes and then your content, and you send it off to the live activity. It uses async await, which is awesome, and it's the future, and away you go. With all this, and I've sort of said it before, you need to be architecting your app really, really well, because things like your live activity, the actual instance that is referring to it, you want to be holding on to that in some way. A singleton is a dirty hack way to do it and not encouraged, whereas something like a service that sits in a property wrapper that can be accessed from a few different places is beneficial, because then you can start it from one method, or if your app sort of gets backgrounded or particular conditions are met, you are able to stop that activity, which removes it from the dynamic island, and that is all good app behavior. So here again, diagrams, because diagrams are awesome. You see the workout activity service is being fed, and bugger off Siri. It's all being fed from our different sources, being Bluetooth, Apple Watch, and call location. Gets fed into there. That will either populate the view model if it's being shown on screen. Otherwise, it can also populate your live activity, which then drives the widget. One of the big questions that people ask is, okay, you background your app, what happens if your app is backgrounded by just like, and it has no sort of, when your app is backgrounded, all of the currently running processes disappear. So if you're feeding in historical data, then backgrounding the app will kill off that unless you have a background task going. If you're dealing with Bluetooth, it will keep funneling in the data as long as you've got the particular Bluetooth mode set, and it's all good for that. But my data was meant to be live. Like when you're cycling, you want to know what are things that are happening at that particular instance. And live activities, like you'll be sending data constantly, and there are ways to get as much data as possible, but at the same time, if your updates are coming at 1/1024th or 1/2048th of a second intervals, then you're going to be sending a lot of data, and iOS just may go, haha, no. Which will be super annoying if you're in the middle of a ride and suddenly everything disappears. Things just to be aware of. Some resources. These are always really good bits of knowledge to be aware of. The Apple's design Higgs, I took some of the screenshots from that. They're always up to date and give best practices. Apple's documentation for things like live activities is super up to date because it's new and modern. Don't look at the Bluetooth stuff. Dub videos are probably better for Bluetooth stuff. Bluetooth.com is where you want to be looking for all of your different bits of specification for like your power meters and heart rate monitors and other devices like that. And Garmin's developer portal is where you would go looking for what makes up a fit file and how to deal with it. Okay, so we've now got our data coming into our app and being consumed and displayed in live activities or in the dynamic island. Where can this go from here? What will be next year's DevWorld talk? We all know this is going to happen someday, and there are constant rumours about it, which is why reality has a question mark there. But live activities and the capability of being able to update the widget is a really good way of, is a potential way that something like a mixed reality headset could be updating the display while you're outside. Stuff like speed, direction, navigation, all of these would be amazing opportunities to make use of all of this. Also, if you're out cycling and you're doing your commute into work, the radar picks up an oncoming car. Being able to see that on a headset instead of having to look at a phone or rely on an audible tone will be really beneficial. Cool. Okay, that's about 40 minutes, which is better than what I thought. So thanks everyone, and hope you enjoy the rest of the conference.
Thanks, Amy. That was great. I don't cycle, but I run, and I use like Strava, and I'm struck with how much more rich data you get from a bike. Like I think a run, it's like how far did you go and how long did it take to get there? That's really cool. We've got time for a couple of questions.
Hey, Amy. Thanks for the talk. So one question I had was, you mentioned that you use SwiftUI for the entire app. Did you find there were any rough edges you ran into when you're trying to implement a certain feature or particular thing in SwiftUI?
Does SwiftUI have rough edges? Yeah, that's blue sky out there. No, it's not. It's cloudy as everything. So SwiftUI has numerous rough edges. Did I have to adapt things to them in order to make what I want work? Yes. I had to take particular design considerations. The navigation hierarchy within the app all needed to nicely fit within Apple's paradigms and structures in order to remain with a single app and target.
Yeah, I have two small questions. One is, do you get any altitude with the watch? Yeah?
Yep, it's all call location, so
Okay.
it comes through even on the phone.
Yeah.
Yep.
And what about the widgets? Like if you're getting live activity on the widget, does that loses as well the connection if you're in the background with the app, or does it work as a separate app?
So your widgets are an app extension, so you need to deal with that boundary. Live activities allows you to shortcut it a little bit, being you can then feed data to the activity, and iOS will make sure that it all flows through. That's good. When you background your app, the app is backgrounded. There's no way around it. But if you have your Bluetooth mode set to accepts Bluetooth in background, then that data through to your CB Central Manager Delegate will remain current, and that keeps coming through.
Great. Another big hand for Amy, please. Thank you.